Here we have a demonstration with 50 gigs over glass optical fiber. We are using a pixel to transmit, and we demonstrate that it is possible to transmit these high speeds with very high temperature for automotive application. So here we have an arbitrary wave generator. With the arbitrary wave generator, we are generating the modulation signal, the transmit signal, in this port, and this port we generate the clock. Provide to the trigger input of the sampling oscilloscope. We combine the RF signal with the BS to drive the pixel that is inside this thermal chamber. In this chamber you can see a PCB where we do the transition between the coax and the pixel. The pixel is behind the optical stage that we use to couple the light into the 50 micron graded index glass optical fiber. After this coupling, we have 40 meters of this fiber. The fiber is a graded index glass fiber that is able to operate in harsh environment between 60 and 200 Celsius degrees, as you can see, with a very, very good mechanical strength properties. The signal arrives to the oscilloscope. As we can see in the screen, the eye diagram of the received signal, as we can see in its input. So we also can be that it's very, very difficult to distinguish the different levels of modulation. We are using a PAM4 modulation to transmit 50 gigabit per second. We use 26.88 gigabaud as a symbol rate, and we can see the histogram of the input signal where perhaps you can distinguish the 4 levels, but it's very noisy and the signal is very distorted. After we apply signal processing, the signal processing consists in symbol synchronization, timing recovery, and adaptive, and using forward error correction, we are able to provide a very low bit error ratio. You can see the histogram of the signal after equalization. You can see here the bit error rate after FEC decoding, and you can see here the modulation error ratio with the histogram of the noise after equalization. So we get intersymbol interference compensation and the whitened noise at the output. It is important to know that we are using a very low current density because reliability is the most important factor in automotive applications. Typically, in order to get these very high speeds in data centers, as they are using the same pixel device at data centers, typically they need to use between 7 and 8 milliamps. But here, in this demo, we are using only 3.5 milliamps in order to increase the lifetime of the device, and it needs to operate at 125 degrees. Thank you very much for attending, and see you in the next video.